Assalamu alaikum dear friends. Today I'm going to teach you about a very interesting sorting algorithm which is called quick sort algorithm. I have also taught you about merge sort algorithm, which was also one type of divide and conquer strategy. So we are going to elaborate further on to this divide and conquer strategy in this video of mine. If you have not seen my video on merge sort, you can also watch that. You can find the link, and do like and subscribe the videos if you find these videos helpful for your exams. Okay, so let's start with the explanation. So first of all, I have told you that this quick sort algorithm is a divide and conquer strategy. It divides large arrays into smaller ones, and it handles the problem in the form of small problem and solve those smaller chunk of problems. So it means that it conquers them by dividing them. So it conquers the smaller parts of those problems, and then it merges those smaller parts after they are conquered. So basically the questions that you can be asked in the exam can be that how quicksort works. You might be given with an array, and you might be asked that how quicksort works. And you can also be asked in your exam that what is the time complexity of a quicksort. You might be asked for worst case, maybe for average case, or maybe for the best case. So depending on the type of question that you are given in the exam, you will have to attempt it. In order to make the concepts clear, let me first of all elaborate on to how does this algorithm work. For this thing, I have considered this array which contains 1 2 3 4 5 6 7 8 elements. So I'm going to tell you the rule of thumb or the algorithm basic key working mechanisms, that how this algorithm works. So first of all, I will tell you these points, and then we will apply them onto this array, and we will understand each point. So you have to consider that you in this quick sort algorithm, you will take a pointer p. So you will take one pointer p, and you will take another pointer q, and you will consider a pivot point. So consider a pointer p which moves towards right hand side, and it will stop when this pointer p is larger or equal to the pivot point. So we will consider one point as pivot, and on one point we will place our pointer, and this pointer will keep moving towards this right hand side, and it will only stop when it reaches when the value of this pointer is larger than or equal to the pivot. Okay, similarly there will be another pointer whose name will be q, and this pointer will move from here to this side. It means that it will move toward left hand side, and it will only stop when the value of the q pointer is smaller than your pivot, is smaller or equal than pivot. Okay, these are the two very important points which we are going to use throughout this example to implement this algorithm. And another important point is that you will add infinity on the right hand side. You will add infinity here, because if your pointer is going and going and it's making comparisons and it is not stopping anywhere, because it is larger than it is not larger than your pivot, and it's moving and moving, so there you have to add an infinity so that you can stop your pointer. So in this question we will be adding an infinity on this right hand corner. Okay, so now let's start. First of all, I am selecting my pivot point on this element 35, and I'm placing my pointer p here, and I'm placing my pointer q here. So I'll make my first comparison. I will say that I will check that if p is larger than pivot. So what is p? P is 50 and pivot is 35. So is 50 larger than 35? Yes. So if it is larger than 35, then it means that this condition has hold true. So this condition was actually the stopping condition. So I will stop my pointer at 50. I will not move it any further. Okay, so the pointer is the p pointer is stopped over here. Okay, now let's come on to the q side. I will make the comparisons of q. Is q look at this point, is q smaller than pivot? So what is q? Q is 45, and what was pivot? Pivot was 35. So yes, q is smaller than 45 is smaller than 35. No, So this second condition is not holding true, because this condition was saying that when q will become smaller than pivot, then you had to stop it. This is the stopping condition for q, and this is the stopping condition for p. So 45 is smaller than 35, no. So okay, keep moving q towards that direction. So now q has moved from 45 to 90. Okay, is 90 smaller than 35? All the comparisons of p and q will be made with pivot. So is 90 smaller than 35? No, 90 is not smaller than 35. It means that this stopping condition is still not true. Okay, so keep moving q more towards the left side. So the q will move from 45 to 90 and from 90 to 20. Okay, is 20 smaller than 35? Yes. So now this stopping condition of q has been met. So we will stop q on 20. So you can see that my p has stopped on 50 and q has stopped on 20. So now when the p and q have been stopped, the next step that comes in this algorithm is that now you will see that have p and q interchanged. Like if has p flipped over q or q flipped over p, you can see that this is not the case. They have not flipped over one another. So if this is the case where they do not flip one another, then what we do is, yeah, so what we do is we simply replace p with q. So you can see here, you can see yeah, you can see over there that you have swapped their elements simply. So this element q has came onto the position of p, and this element p has came onto the position of q. So only the positions of p and q have been flipped or swapped, and this is the only condition which becomes true when these pointers have not crisscrossed each other. I hope I'm making sense that crisscross, what crisscross means. Crisscross means, for example, if p had came somewhere over there on 90 and q had been on 20, so it means that p has crossed over from the limits of q. But right now p is just stopped over on the very left hand side, and q has not reached till p. So in this case we have simply swapped the values of p and q. So now if you look onto this array, you can see that a little sorting has been done, but still the elements are not sorted. So we will continue this quick sort algorithm further. All right, so now again I'm going to start, and my pivot position is the first element 35. This 20 element has been assigned with pointer p, and this 50 element is assigned with pointer q. These are the same pointers, I have not changed them, they are on the same positions where I left them before. Okay, so now I'm going to make the comparisons of pointer p with pivot. So is p larger than pivot? So p is p is 20 larger than 35. Yeah, first of all it's 20, because p is on 20. So is 20 larger than 35? No. So the stopping condition is not true. So p will move from 20 to 15. Okay, is 15 larger than 35? No. So stopping condition is still not true. Okay, is so now p is over here. Is 25 larger than 35? No. Okay, now the p pointer is moved to location 80. Is 80 larger than 35? Yes, of course 80 is larger than 35. It means that stopping condition for pointer p is met, and we will stop p here at 80. Okay, similar method will continue for q. Q is 50. Okay, so now start moving q. Is q smaller than the pivot? I mean to say that is 50 smaller than 35? No, it means stopping condition is not satisfied. Let's keep moving q. Okay, q is now moved on to 80. Is 80 smaller than 35? No, stopping condition has not been met. So keep moving q, q will reach here. Is 25 smaller than 35? Yes, so stop q here at 25. So now you can see that this is your new location of q and this is your new location of p. So now check, have p and q crossed? Yes. Now this condition has become true. So now p will be replaced, pivot will be replaced with q. Previously we simply swapped the locations of p and q, but now in this case we will replace pivot with q. So you saw that the pivot was 35 and q was 25. So this 25 will move on to the position of pivot and this pivot will move on to the position of q. So this is the different case that has happened here, and it has happened because p and q have crossed by then. So now you can see that my first pass has completed. The pivot which was number 35, it has reached its right position. What do I mean by right position? By right position, I mean that all the smaller elements which are smaller than pivot, they are on the left hand side of pivot, and all the elements which are larger than pivot, they are on the right side of the pivot. I'm not saying that the array has been sorted out. No, the array has not been sorted out yet, but yes, the pivot has reached its right position. So now I am able to divide my array into two sub arrays. So you can see that in this next diagram, you can see that this is my array, sub array 1, and this is my sub array 2. So I will simply exclude this pivot element, and on the first sub array again I will make a new pivot, a new pointer p and a new pointer q, and I will again start repeating the same steps. I will say that with this new pivot and this new pointer, let's make comparisons. Is this p larger than pivot? I mean to say, if 20 larger than 25? No, this is not true. So it means that stopping condition has not met. So let's move p further. Okay, so p has moved to 15 now. Is 15 larger than 25? No, 15 is not larger than 25. It means the stopping condition for p has not been met yet, so we can move p further. Okay, so p has reached here. So you remember I told you that we need to add infinity to stop p, otherwise p will go and reach Denmark. It will not stop. So now I will compare that. Okay, p has reached infinity. So is infinity larger than pivot? Yes, of course, infinity is larger than everything. So finally p will stop at infinity, right? Okay, so now let's start doing the same process for q. When we start doing the same process, we say that is q smaller than 25? Because you know 25 was your pivot. So is 15 smaller than 25? Because you can see that you can actually, you can see that your q was on 15 and your pivot was 25. So that is why I'm saying that let's compare 25 with q. So 15 is smaller than 25. Yes, this condition is true. So we will stop q at 15 because the stopping condition has been met. Okay, so now we will check that p and q have crossed. So you can see that q is on 15 but p has jumped over to infinity. So yes, they have crossed, and so now we will exchange the pivot with q. So previously this pivot was 25, it will jump onto the location of q, and this q is 15, so it will jump onto the location of 15. So you can say you can see that this smaller sub array has been sorted out. Previously you saw that this was the sub array, it was not sorted out, but it is now sorted out, and I will now start working on this second sub array. So friends, I hope you can understand the steps that I'm following. It is quite it's a tiresome sort of procedure when you do it manually. Of course, in the computers this is very much easier because computers do them very quickly, but of course in the paper, if you are given a question to use quicksort, then you will have to do it step by step. And these are the steps, these are the basic rules, that you always have to move your pointer P and you have to move your pointer Q. Okay, so similarly, now we are going to follow the similar procedure for the second subarray. We made a pivot on the first element. We placed a pointer here and a pointer here. So is this P larger than pivot, like 50 larger than 80? No. So it means the stopping condition is not true and you can move P further to the next location, 90. Is 90 larger than 80? Yes. Okay, the stopping condition is true now, so you will stop this pointer P on 90. Now for Q, is this Q smaller than your pivot location, like is 45 smaller than 80? Yes, it means your stopping condition for Q is true, so you will simply stop the Q at 45. So it means that Q will be here and P will be here. So now check that have P and Q crossed each other. No, they have not crossed. So in this case, when they do not cross, we swap P with Q, not pivot with Q. So this is the difference. In the case of crossing, you swap pivot with Q, and in the case of no crossing, you swap P with Q. So now this this Q has been placed here on the location of P, and this P has been placed here on the location of Q. So if you look at this smaller array, you can see that it is still not sorted out. So let's do another iteration. We make this pivot, we place P, we already have so now again pivot is 80, we place P on this element, we place P on this element, and I'm going to compare P with my pivot. So is 50 larger than 80? No, so it means that stopping condition is not true for P, so we will move P from 50 to 45. Okay, so is 45 larger than 80? Always remember that when you are making comparisons for P, you use this larger than equal to sign, and when you're making comparisons for Q, then you use smaller than sign. Okay, so is 45 larger than 80? No. Okay, you can move P to the next location. Is 90 larger than 80? Yes, of course 90 is larger than 80. So we are going to stop P at 90. Thanks God, P has stopped somewhere this time. Previously P was going to hit into infinity, right? Okay, so now it's the turn for Q. So is Q smaller than pivot, like 90 is smaller than 80? No, it is not smaller than 80. Okay, we can move Q to one location back. Is 45 smaller than 80? Yes, so we are going to stop Q here. So Q is stopped here and P, reached over there. So now you check that P and Q have crossed. Yes, they have crossed. So we will swap the pivot element with Q. So 80 was my pivot element, so it will come onto the location of Q, and Q will go on to the location of pivot. So now if you look at this subarray, you can see that it is in a sorted form. So this is my second subarray. So I'm simply going to join these two sub arrays which I have sorted separately into one array. So friends, this is the complete explanation of the quicksort, that how you do it. And if you are asked in the exam that how you are going to solve the quicksort, then this is your explanation. I hope you like the video. Thank you very much. Allah Hafiz. Do subscribe to my channel and do acknowledge the efforts.